Hello, my name's Sam Stevens. I head up digital across S&C level and nuclear sector. And today we're going to talk about how digital twins are transforming the way we deliver decommissioning, planning and delivery across our markets around the world. Joining me today is Darren Greers.
Hello all, Darren Greers here. I am the Director of Digital for our EMEA region, so I look after digital and products and technology within our UK, Middle East regions.
Now, across the markets we work in, delivering decommissioning solutions, particularly across the UK, Canada, USA and Japan, we see common challenges faced by our clients. First and foremost, we often see the need to start engineering modifications and decommissioning planning, but using existing 2D record drawings that were often drawn by hand as part of the construction of the facilities, sometimes over 30, 40 years ago. Now, while these are often comprehensive, they haven't always been updated since the facility was built, and particularly aren't compatible with a 3D model-based engineering workflow that we use today. We also see quite a number of other challenges when working with decommissioning sites. When walking down sites, we see a need for multiple subject matter experts from across the engineering disciplines, but also in the wider supply chain. And with all this uncertainty in the information that we pick up at the beginning of a job, it requires us to make assumptions and then bake in those assumptions into the cost and schedule, which can increase cost and also increase the duration. And with the information that we do have, where there are gaps, our plans and estimates based on these assumptions are also then based on takeoffs from those drawings, which may or may not be correct. Finally, we recognise that there's an ageing workforce, and particularly with decommissioning sites, as people walk off the site at the end of their careers, they take with them an immense amount of valuable knowledge. So our approach to address some of these challenges to adopt digital twin concepts to support decommissioning planning. Just over 2.5 years ago, Atkins and the UK Institute of Engineering Technology worked together to define what we mean by digital twins for the built environment. And together we published our digital maturity scale that recognises that digital twins can range right from simple point clouds and 2D, 3D models of plants and buildings, right through to fully censored up with sensors and integrated data throughout the operation of the plant. And particularly in these early low-level maturity, from level 0 to 1 to 2, we see immense value for decommissioning programs. Firstly, by capturing the data from site, and then creating 3D models from it in order to use to support engineering on sites and decommissioning planning, and then integrating more data, such as 4D, delivering 4D approaches by integrating P6 schedules, and then also bringing in a 5th dimension with cost. And ultimately, where clients opt towards safe store or have longer term operation facilities on their decommissioning site, we can see the value in integrating sensors and other data sources into the 3D model, into the digital twin. The first step of this is reality capture.
So as Sam outlined in the introduction, we don't really have confidence in some of the legacy information. So the paper-based drawings or the information that we have for legacy facilities that sometimes can be 40 or 50 years old. So in order to address that, we use a number of different technologies and various different scales and various different speeds and various different accuracies in order to have assurances and increase that confidence. Now, as you can see on the screen, there are numerous technologies available to us now in order to generate that reality of sight and increase that confidence. So we start with something really simple and straightforward, a 360-degree camera, such as a GoPro or a Ricoh Theta or something similar. really cheap technology, really available and commercially off-the-shelf technology that has the ability to produce a high definition 360-degree walk down, if you will, of plants and facilities, and generate 360-degree photos or imagery. This can actually be undertaken to generate a full sort of visual walk down of a plant or a number of plants within an afternoon. The beauty of this as well is that obviously the technology is cheap and available, but also I think it's quite easy to be sucked into that. When we're talking about decommissioning radiation and rad tolerance devices, we immediately jump to, is this rad tolerance, and therefore should it be nuclearized and the costs associated with it. When we have actually deployed things like the GoPro and other devices that are commercially off the shelf, we found that they've been able to deal with actually high levels of radiation. So you don't immediately have to jump to, we need something nuclear and protected and shielded. Second to that, we have what's called SLAM-based technology, which is basically handheld rapid facility scanning. So before I get onto terrestrial laser scanning, where SLAM-based scanning is handheld, similar to a 360-degree walk down, but a device that allows you to rapidly generate a three-dimensional representation of your facility. Now, in comparison to traditional laser scanning, you compromise on its accuracy. However, you're able to scan an entire facility or a number of facilities within half a day or days. So the ability to have that sort of accurate model to represent really quite rapidly is where SLAM that comes into it. We then move on to terrestrial laser scanning. So that is your tripod, the more traditional things. If everyone's seen a laser scan, it's usually that they've seen a LiDAR or laser scanner mounted to a tripod and a surveyor standing near to that or next to that. Now, again, with both the rapid scanning and the terrestrial scanning, this is the equivalent of the 21st century tape measure, because essentially we're taking millions and millions of dimensional points rather than going out and doing handball dimensions with that. Now, again, from a compromise point of view compared to rapid facility data capture is about time. So there may be specific areas where you want a high accuracy or high resolution scan, and therefore terrestrial laser scanning is appropriate. But in order to, say, scan an entire facility, that could take days, if not a week, in order to generate that high accuracy. And from a decommissioning point of view, do you really need that? So it's about choosing the right tool for the job in terms of where you want to be and being pragmatic about that. There is also other sensors and other bits of capability to capture the reality within decommissioning, such as radiation and dose mapping techniques, where LiDAR plus gamma probes are joined together to create three-dimensional dose planes or three-dimensional dose maps of facilities. So you're able to join your SLAM or your terrestrial laser scanning data with dose mapping and then produce a 3D model of all of that information. And there are other sensors that have similar capabilities, but obviously dose being a key one. And here we have UAVs or ROVs or autonomous vehicles on both of these, where we can fly drones around in order to not have to say erect scaffold to do inspections or to generate the data that we need to put into the decommissioning digital twins. That allows us to create large scale videos, pictures quite rapidly. So again, in terms of that time to get that information, you could do an entire site in a few hours in order to then generate a 3D model or a point cloud from that data with a UAV. And then the final bit on this is about what the future state is. Where are we going with this? And the use of autonomous vehicles, whether that is ROVs or things like you can see on the screen, like Boston Dynamics Spot, where you're able to mount a number of sensors, almost all of the ones that you can see here, such as a GoPro camera, a terrestrial LiDAR scanner, a dose map, mapping technology, and mount that as a payload on the back of these vehicles like Spot, and then move into, can we actually not put people at risk by setting these ROVs or these UAVs, these autonomous vehicles off to go and do the routes that we would do, not putting out people generating dose and collect that information autonomously, but also keeping that refreshed and up to date, so that if we need to generate the same information for sequencing or to keep the information up to date, then we could set autonomous vehicles such as UAVs, such as Boston Dynamics Spot, to go and collect and capture that information on a regular, scheduled and repeatable basis. Now, it's all well and good collecting all this information, but as with all LiDAR information and with this type of information, it's usually large in scale. It's usually heavy in gigabytes and storage requirements, and it's also quite difficult to access, requiring high-spec PCs, graphic cards, and actually quite inaccessible in some of these bits. So there are platforms out there that can do that, and one of these such platforms is one that we've developed ourselves called Cirrus Insight. Now, some keywords, and the reason why we've developed this ourselves here is because it's secure. It is built upon our systems, of which we have approvals to host nuclear data and other sensitive information up to official. So there's confidence there that the way that information is managed and hosted is secure and being approved by the clients that we've got there. It is web-based, which means that it does not require specific software. It does not require a high-spec PC. It just requires an Internet Explorer and log in to the data, which means that it's actually really quick and rapid to view and analyze large-scale parts of that information. It's able to then view all of that data that has been collected using that technology, so 360-degree videos, images, drone data, LiDAR scans, SLAM data, all of that is hosted on this and viewable through that web browser. And then obviously it can act as a common data environment for this type of information as well. So it conforms with all of the security standards, it conforms with the conventions that they should do in terms of structuring that data, and it makes it secure and accessible all through an Internet Explorer, making the data available to those who have approval for that information. Now, once you've collected that reality capture information, it's then about what do we do with that next. Now, as I mentioned before, using LiDAR, using terrestrial information, that generating a really high accurate model in order to then make better decisions and have that sort of, this is my old plant as it currently stands, and therefore creating that configuration baseline. Now, what we then want to do is we want to apply that technology pragmatically. Do we need to convert all of that into a 3D model? No. Do we need to convert some of it to a 3D model? Yes. Does that 3D model need to be nuts, bolts, really details, high level of development as meetings the sort of BIM specifications? No, but we definitely want to generate some three-dimensional information in terms of supporting decommissioning planning. So for example, if we want to do low-level representations such as cubes, cuboids of items within an area, because we know that they are going to be identified as waste, or they are going to be deplanted, or they're going to be deconstructed or demolished, etc. And so therefore we take that approach of using the tools that we have to semi-automate the conversion of point clouds to 3D models, and therefore we're able to use that three-dimensional data for various usage, such as waste volume estimations. So there is software that we use to rapidly convert point clouds into 3D models, such as concrete, steelwork, piping, plant and equipment, cabling, etc., and use that to then for things such as characterization or for waste volume estimates. We then want to, as we outlined, about integrating all of this data into one. So if we have those 3D models, we have those waste volume estimates, we have the program, the decommissioning programs, then we're able to join all of this information and generate those 4D and 5D modeling to visualize the deconstruction program and generate the waste volumes that would come from the back of that. So it's almost like when we're approaching this from a new build point of view, you might say, well, we have a 3D model, we have a program, we would join that together to generate the construction, the construction programming and planning in 4D and 5D models. This is just flipping that around, essentially, where we're showing how this will be deconstructed, in what order, and therefore what waste, what volume, what other information do we have associated with that. Another benefit of the technology that we've used on here is live streaming. Now, I mentioned before about Cirrus Insight being secure and being hosted on here. on the right cloud-based systems. We also have the ability, and there's also technology out there in order to do live streaming from nuclear sites. So there are examples where we have deployed live streaming technology onto nuclear site license sites in order to, one, do stakeholders and therefore minimize the number of people who are on site. Two, not put those people at risk. So join that up with activities that are already occurring on site, and therefore we can have a high stakeholder with people all over the country being able to virtually visit site. This has a number of benefits in here. So as I mentioned, risk reduction. We're not nuclear site license sites are hazardous environments, whether they are conventional construction or deconstruction risk, if you want to put it there. But also there's a radiological and dose element to this, so that if we don't have to have people on site in order to do stakeholders, walk downs, make decisions, etc., then actually we're reducing the risks to our workers, to your workers, to our clients' workers, etc. There's a sustainability part of the element of this as well, which is due to the pandemic that's occurred, due to the skills where they are. We've got people within the industry who are all over the country who are travelling to these licensed sites. And it should also be noted that nuclear sites are usually located in geographically hard places to actually get to. Therefore, sustainability here is that from your home office, which may actually be your home office due to hybrid working in the way that we are with that now, or from your whole organization's home office or another office, you're able to visit site without actually having to travel, and therefore carbon footprints, sustainability targets, reduction in those types of activities. And then if you use the right and appropriate technology, such as presented, you can obviously use augmented reality to overlay information. Now, this again helps us then make speedy decisions, to troubleshoot design reviews, to really overlay the information that's being collected as part of that reality or as part of the design. And therefore, we're able to make decisions quicker, whilst also reducing risk and reducing things like our carbon footprint. Now, an example of where all of this has been stitched together is where we've delivered a low-level digital twin, decommissioning digital twin, for an experimental reactor for a client in Canada. Now, this started with as a consultancy exercise of actually being able to tell them, well, what do you actually need? If in order to really get the value that you need to plan the decommissioning and the deconstruction of this facility, what would a digital twin look like? And as Sam alluded to in the introduction, there is a scale associated with that. So this was about maturing the information and maturing our client at the same time to be able to work with and accept this data, but also only taking a pragmatic approach to this of establishing that digital twin and what type of information should be in there. So this started with a reality capture exercise where within Canada, the client was actually scanning the facility themselves. We then actually supported them in ensuring that data was collected correctly, that we then processed, validated and verified that information, but supported in upskilling them in order for future collections of that information. A sort of global, if you will, a scan to BIM conversion activity occurred where we took a pragmatic approach to generating the appropriate level of detail 3D models with the both Canadian and UK team generating different structures, different parts of the items and splitting that work up. So we then ended up with a 3-dimensional model that was built on a foundation of reality capture. So therefore, both of the models were tied together and therefore accurate in order to then move into the next phases where they may want to then plan, program and join their 4D, 5D and waste volume analysis. Full process in terms of validating and verifying that. And then actually, when we have these different data sets, and they are how do we bring those together in order to get the most value out of that? So we generated an application using the Unreal Engine, which you'll find is being used and adopted same as with Unity. So gaming engines are actually used across industries in order to create the sort of graphical interface. on this, where you're able to then join all of the data that we generated, 360-degree photographs, 3D models, the use of immersive technology such as virtual reality, all to be able to visualize and get some value out of this data to then start the planning as part of that. And all of that was then delivered on a secure laptop, and hosted them at sort of standalone, so that they're able to then do what they need to do from a security point of view, but obviously on a high-spec PC if they do want to use immersive visualization technology.
So back in the UK, we've built upon this type of approach and captured laser scan data for the fuel route in one of the UK power stations that's coming to the end of its life and entering decommissioning. And rather than taking a 2D approach to the design, we took an entirely 3D approach, laser scanning facility, and then designing all the modifications required to support the increased fuel route capacity required to support defueling. We then delivered a VR, virtual reality application to the client to enable them to do the design review in virtual reality, with great feedback and great engagement from the operators and all those involved in the project, as it really gave them the opportunity to experience the design before it was even built. This allowed them to identify areas of pinch points, any areas where accessibility would be difficult, and for them to fully understand the design intent before committing to expenditure. We've also taken a digital approach to reactor pressure vessel segmentation at a site in Lingen in Germany, where we were contracted to segment the reactor pressure vessel. And starting with information on site, we developed a 3D model and embedded metadata from the radiological dose inventory into that model. And rather than taking a traditional approach to cut planning, took an entirely 3D digital twin based cut planning approach, which enabled us to rapidly iterate and refine our cut plans. Furthermore, once we'd developed the initial cut plan, we were able to assign each segmented piece to a waste box and then conduct automated assessment using codified Python scripts of the waste compliance assessment process in Germany. And this took a traditional process for waste compliance of around 11 hours per box down to a matter of a few seconds. And so taking a digital approach right from the outset enabled us to use the 3D model to arrive at optimized cut plans, but also optimized waste storage plans. Finally, with some of the cutting edge digital twin work that we're doing at the moment is to support the use of collaborative robots in glove boxes in the UK. This is where we're looking to substitute lightweight collaborative robots for human arms in order to undertake a number of decommissioning and post-operational clean-out activities in legacy glove boxes. And one of the opportunities for digital twins is to provide a training and operational aid where the operator can move the robot in virtual reality and instruct the robot to do specific operations, picking and placing, cutting and moving items in an intuitive and easy to use environment, as you can see here. It also enables us to record activities, to then repeat them, or even rewind them should a mistake be made, but also rehearse those activities before we get on site. So we can see that by embedding digital twin approaches, we can then provide point cloud data plus 3D models, plus then kind of operation and control systems, and increase the opportunities to bring robotics into the work that we do. And the solution that we've developed here, we see as being kind of highly scalable to much larger tasks on site, where there may be remote operations and remote solutions, kind of long reach tooling required. So to conclude, we can see a number of benefits from digital twin approaches for decommissioning planning. By capturing data early on in the program, we can upload it to secure cloud platforms that make it accessible to all project stakeholders and the wider supply chain, in order to build confidence in knowing the current configuration condition of sites. We can highlight hazards much more intelligently by highlighting radiation information and other hazards identified on site to operators, either remotely through a desktop or on site by overlaying information in augmented reality. We can conduct better waste planning and waste route planning, and also waste estimation, which is a key driver of cost for decommissioning sites. And then once we've collected all that data, we can use it throughout the decommissioning program in order to support engineering delivery. These three key use cases of liability estimation, contractor scope specification, and engineering delivery, we can see digital twin approaches delivering value right across the decommissioning program. Thanks very much for your time today, and we look forward to take any questions that you have.
Hello, thank you both. A really interesting presentation, Sam and Darren, and it's really clear from your presentation that drones and building information modelling, cloud storage and everything is really being embraced within the nuclear industry. I know there's been a history in the conventional side for a while, but it's good to have some real case studies from across the world, so thank you for sharing that.
You're welcome.
So there's still the opportunity for audience to put in some questions, and I can see that they're coming in. But I'll kick off with one for Sam to start with, and it's about some of the potential issues. It says gathering multiple siloed data sources and experts is a major challenge. And what recommendations can you give to operators and organisations like looking to use digital twins? How can they improve confidence in their existing records using your models?
So I think firstly, when I think about this question, I look to some of the work that has been done in the wider infrastructure sector, but also on some of the new build power stations that we're working on at the moment. And the key here is really adopting from the outset information management principles, such as ISO 19650, which is the standard for information management and information sharing on building information modeling projects. And for us, this is a key step in adopting these principles set out in that standard, in order to set the conditions for information sharing among the supply chain and stakeholders. And a key part of that is then having a common data environment set up, and in that respect, being clear on kind of what the common data environment is, and where that information will reside to support the decommissioning program is really important. And I think one thing that we are seeing as well is that as you shift to cloud-based solutions with that common data environment, it opens up more opportunities to integrate with other data sources and other solutions. It means it can be much more agile. I think in terms of digitizing existing records, I think there's obviously we set out quite a lot of the approaches that we take to digitize the existing 3D existing buildings and turn them into 3D models. There's obviously still a huge amount of data that operators hold, and we're looking at kind of various processes for neural language processing of those data sets in order to quickly gather and understand them as quickly as possible. I think some of those approaches are still kind of slightly lower TRL than what we've set out here today, but I think that there are opportunities that we can see over the next 3 to 5 years for that type of approach.
That's amazing. Thank you very much, Sam. We've had another question, and it's regarding the use of, it's regarding dose mapping, and it's asked if you can share more information on the techniques or products that you use to do the dose mapping. Darren, can you provide a bit more detail, please?
Yeah, absolutely. I think a key thing for us is that there are subject matter experts in this who have the technology and capability to do that, and where we see ourselves is integrators or domain knowledge of how we want to apply those techniques. So it's not something that we've created ourselves. It's available technology from the supply chain that we would then bring to the table. So in the examples that we've sort of shown you in the presentation, we've used predominantly engaged with two organisations who would consider to be leading in this field. That is Createch and Gamma Reality. They have the devices that can create three-dimensional dose maps and dose planes, and can all be collected in a similar way to the LiDAR or point cloud technology that was showcased earlier in the presentation. They have similar forms. They come in similar forms to the two different techniques I outlined, which was a SLAM-based methodology as well as a terrestrial-based sort of methodology on capturing those clouds. So there are devices that are handheld that can be walked around by an operator, and that will create a three-dimensional dose map. But there are also more fixed tripod-based devices from Createch and Gamma Reality, who can then take more a traditional approach for, say, deploying through penetrations into cells and mapping the areas.
Okay, that's amazing. Thank you. And on a similar theme, we've got a question relating to how much work you've done with integration of dose and contamination survey data into 3D models. And if you've done this, can you share a bit more detail on the benefits you've seen, please?
Yes. I mean, as I say, it is pretty early. So we do have more of an aspiration for this to become business as usual. It's been on a case-by-case and a project-by-project basis. But in the examples that we sort of shown on that project, where we've managed to join all of that data together is also sort of visualizing the risks that you can't see, and bringing all of that together into one location. So you have all that data in a graphical form within your digital twin, which means that you can make better decisions quickly rather than having disparate information pod there. Another key part of that is if you are generating those planes or those three-dimensional dose maps, one of the benefits we have seen is been then taking it into other technologies such as augmented reality, where on site we have operators who are using devices like the Microsoft HoloLens 2 are able to actually see radiation dose when they're on site, which is therefore making a hazard, making the hazard seen, and making that unseen hazard visible for people to be able to plan activities and be able to de-risk those activities. So whilst I still think it's at an appropriate TRL to actually utilize now, it's still quite early, and it's how do we bring all of this together. But we're already starting to see benefits on projects as to how all of this joined up and be able to utilize that on site.
Okay, fantastic. And you mentioned benefits a minute ago, and on the final slide, obviously you highlighted many benefits or potential benefits of using digital twins. Call me a cynic, but I mean, can you give some insight into the drawbacks? And we've had a specific question relating to cybersecurity concerns, but more generally as well. Like, I don't know if.
Well, let me take the drawbacks, and then I think Darren can cover the cybersecurity bit, because that's one of his kind of passions. I think one of the drawbacks that I see is actually the time required up front in a program in order to set up, to gather the data and set up the models. And I think from in that respect, we try to take quite a pragmatic approach to it in terms of kind of modeling what you need to model, keeping the data as raw as possible for as long as possible to maintain that accuracy, but also avoid converting large amounts of point cloud into models that then essentially you're going to be seeking to kind of rip down the building and dismantle it. And so I think there's that kind of intelligence required in order to avoid kind of undertaking huge amounts of kind of upfront work in modeling. So I think intelligent application of the tools and processes is really, really important. And with that, then I think you can much more quickly identify the areas where you do need greater certainty and do need greater confidence. And then obviously then use that 3D model to bring in the additional data and the additional information as it becomes available. So we're very much about kind of a progressive, pragmatic, but iterative approach to this throughout the program.
That's amazing. Thank you very much. And Darren, on the cybersecurity question, are there any issues or concerns?
Yeah, absolutely. I mean, to be honest, if we talk about digital twins and building information modeling and common data environments, this is actually an attempt of bringing all information together and making it more accessible, which is actually a fight against keeping things secure and breaking these things down. However, I think there is a sort of level of understanding that there are ways and means of being able to deal with this. You know, security and of storage, even in the use of cloud-based systems, is really important. And where we found is working with our clients' sort of cyber security and information assurance teams at the very beginning of a project or prior to this, and putting the right processes and procedures in place, of which there are many ways that we can utilize, ISO 19650 in a way that actually provides a level of sanitization or desensitization. So, you think about proliferation of information, that's what we're trying to do with a digital twin, but we're also able to utilize certain systems in the right ways by, say, changing a naming convention and keeping the key in a secure area, segregating data in the appropriate bits so that no one has access to the whole picture, or sanitizing information by removing bits out of the point cloud or blurring things out of imagery and photography in order to remove things that would elevate it beyond certain bits. So we've actually found engaging with, what we would consider to be really secure data that needs to be stored and secured appropriately. Once you start breaking those down and putting the right data standards and information management standards in place, it becomes relatively easy to keep it at an appropriate level so that actually security isn't a major issue as part of that. So I think there's a cultural thing on that as well, where we say, this is nuclear and therefore it's sensitive and we should do that. But actually we're starting to see, and I think it has been driven by hybrid working and COVID and people not being on premises and having to adopt cloud-based technology to share with the supply chain, share with people who are working from home, that our clients and our partners are becoming more acceptive of these types of storage solutions, as long as we put the right things in place to do that. And it's just a case of really early engagement with the appropriate security bureaus and areas and people, and getting them on board and working hand in glove with them literally to say, we want to do this is for the benefit of your projects, we're going to see this value out of it, let's work together to put the right things in place. And we've seen that over the past 2 years, which is why we have been able to put what we would previously have considered to be sensitive information in cloud-based storages, all with the backing of our clients' sort of information assurance teams.
Yeah, that's brilliant. Thank you very much, Darren. We've just got time for one more question, and it's a quick answer. It wouldn't be a decommissioning conference without a question about cost. And it says, using digital twins to optimize waste disposal, i.e. cut plans for storage, seems to save time. Does this suggest a quicker overall decommissioning process? And if so, by how much? Actually, wasn't about cost, but time is money in decommissioning.
Yeah, absolutely. So I think some of Darren's experiences up at Sellafield have been kind of really transformational there, in that there's kind of modifications carried on site, scheduled to take 12 weeks, and were delivered in 8. And I think that's the sort of mindset that we want to be approaching with digital solutions, is actually really looking to kind of drive those benefits. I think there's also the benefit of actually delivering on time as well, because I think so many nuclear projects, kind of the schedules, programs drift to the right. Actually, I think delivering on time and on budget is actually, and having that project certainty is immensely valuable in itself. But actually, I think also the approaches that we propose, we see that when you actually look across the project lifecycle from concept design, detailed design, through to any installation, commissioning of equipment to support decommissioning, through to then the process itself, and then handover. Actually, if you there's potential savings right at every step throughout that process, and actually then if you add it up right across the project life cycle, you know, the savings could be as much as a quarter of your overall budget in terms of improved design, but also optimized and much more efficient construction and delivery.
That's amazing. Thank you, Sam. I think we need to wrap it up now, unfortunately, but we'll follow up with any other questions. The next session is about to start, and it's about robotics used at Fukushima. So I hope to see you there. And thank you, Sam, Darren.
Thanks very much for your time.
Thank you.
Okay.
Bye-bye.